Hello, I'm here to talk today about the definition of complex numbers and how this relates to algebraic operations on complex numbers. In particular, we're going to talk about why b here can be equal to a number like this. Okay, so here's how this works. So let's say the definition of a complex number is a descriptive definition. So complex number attempts to describe some number. And then the question we have to ask ourselves is this actually a good description? Is this description accurate? Well, if the number takes the form a plus bi, and a is a real number and b is a real number, then, right, that's an accurate definition. But if it turns out that a or b are not real numbers, then we may not have an accurate description, in which case the description needs to change. But it's not sufficient for a proof to state that a number is described as being complex, and then when it turns out not to be a complex number, to then say that therefore it can't be because the number is supposed to be complex, and so therefore this cannot have a value like I over 2, because it can. It's just that the statement that this is a complex number would no longer be true in that case. But that's okay, right? That's mathematically possible. It's just, these are not prescriptive definitions, okay? Complex number is not prescriptive. It does not state what must be the case. It just is a description of some number and that description can either be true or false. So, for example, let us say that we have a plus bi, but we don't know what a or b are yet. And now let's say that we want to look at this value in the complex plane as a two-dimensional number. And let's say that a is here and b is here, just for hypothetical purposes. And likewise, we have negative a and we have negative b, negative a, negative b. So a plus bi, therefore, is going to be here. Now, it's a common operation in complex math to rotate this value in the complex plane, and we're going to rotate it by just multiplying by I. Okay, so I times a is going to be ai, and then I times b is going to be bi, and then I times I times bi. So you're going to have bii here, right? And that's going to then end up being ai minus b, because these two evaluates to -1. And then, right, now we have essentially this complex number. Okay? And so now this point is going to rotate over to here. Negative b. Okay, so our new one's right here. Now, clearly, right, the fact that that b was now no longer complex did not mean that we have to stop doing math, or that something is. I mean, we can still do this. It's just now that it's swapped. Now, what happens if it turns out that the value of b equals negative I over 2? Okay, well, what happens in our original statement, right, if we get rid of all this, We get rid of this. Get rid of that. Okay, so we're just going to say what happens if b equals negative I over 2. Okay, so we now will have a plus negative I over 2 times I. Okay, and then we're going to then say, right, I times I is negative 1. Make that negative as positive 1 over 2. Now, you could say not a complex number anymore. And you'd be right. Right? But right, you could also say plus 0I. Right? Because remember, the complex plane contains all the real numbers in it. So this is still a complex number. It's just a plus 1/2. So wherever a is plus a plus 0.5, right? With no complex component. So again, this is not an invalid number. Not even if it was a complex number, we could still say it's complex. It just doesn't have an imaginary component anymore because this canceled it out. But that's no, unless you have some other math in your proof that requires that this be a non-zero component on the imaginary side of things, which perhaps you do, and I haven't read your proof correctly, but unless your proof requires this to be a non-zero value, right, then this is not an invalid operation, right? You can do this, okay? And also I would point out that what happens if a, because if we don't know what the value of a is, a could very well turn out to, if a equals, right, if a also equals negative I over 2, right, all of a sudden, now this number is going to be complex again. It's going to be 1/2 minus I over 2. Or in other words, 1/2 minus 0.5 I. In which case, right, we're somewhere if that's 0.5, or I'm sorry. So we would be at 1/2 here, and then down here. So it would be something like in there, I don't know, right? So, right, because that's going to be negative 1/2 there, and that's positive 1/2, right? And so that's where our point would be. Right, but again, in math, right, just because you say a number is a complex number, that doesn't mean that now some coefficient variable suddenly can't have I in it because you've given it that definition. It can, it's just that now that definition has to change, right? So now, or it could have to change, but it doesn't have, I don't see why it has to, unless we've suddenly ended up with like a plus b well, no, I can't think of a reason why it would have to change. Yeah, anyway, so I hope that makes sense. Please, in the comments, let me know if you think that I'm somehow wrong.